So, problem 3. A simple pendulum consists of a bob of mass 1.8 kilograms attached to a string of length 2.3 meters. The pendulum is held at an angle of 30 degrees from the vertical by a light horizontal string attached to a wall as shown above. Draw a free body diagram of all the forces acting on the bob. I am going to start this one off by drawing another system schema. We need to think, what is all acting on my bob? So what's acting on the bob? Well, the bob is of course acting with the entire Earth. Then we have the horizontal string, right, is what we're going to call that. Then we're going to have the other string, which I'm going to just call S, going on. Well, what else is my bob touching? I've got my two strings and I have the Earth. If you can't tell, by the way, this is a ceiling and a wall that we're attached with. So my bob is interacting with each of these things once. The Earth is also interacting with the strings, but since this is a light, or it says a very light string, the mass is almost irrelevant, and therefore we don't really care about that interaction. Because of that, all we need to realize is that if we are looking at the bob, we should expect to see three forces: the Earth, the horizontal string, and the other string, this guy up here, interacting. So let's draw a free body diagram. Here is my dot for my representation of my mass. And then I have my force due to gravity going down. And now we have two strings, which are both tensions. Because it's a pull, it cannot be a push. So a mistake we made was we thought these might be pushing in different directions. Well, if these are both strings, they can only pull in the direction that they are. So this horizontal string will pull this far. I kind of just eyeball this one, and if I feel like I need to adjust something, I can. So this is my force of tension. I'm going to call it due to the horizontal string. And then this tension goes up at an angle. So I'm going to try and draw this at a relative angle. But here's the deal. I know I'm just hanging here. So my sum of all forces should be equal to 0. My other tension will go something like this. Why did I draw it that long? Well, I see that this x component needs to balance out this x component here. But notice now my y component isn't balanced. So this guy has a y component that's way too big. And so I know force of gravity needs to be a little bit bigger. There we go. That's better. So notice if I were to vector sum these, I would get something like gravity going down, this tension force going up as such, and this other tension going this way, and so they would balance out. I'd have a sum of 0. That's our free body diagram. All right, in part B, we talk about that in a similar situation, the angle of the pendulum is found to be 50 degrees, so this angle is going to be different. And the string attached to the wall remains horizontal. Draw a new free body diagram for this situation with appropriately changed magnitude to end direction. Also, how does the force exerted by the horizontal string change and why? Well, if I were to draw on top of this image over here, what happens? So this angle is now 50 degrees. The only way this is possible is if this string can connect somewhere else. Well, let's say it does. So this is a little extreme of an example. So let's say my string goes like this. This angle of 50 degrees. And I want to know what's going to happen with my new free body diagram. What we should see is this tension will change. And so gravity is going to remain exactly the same. So I can just copy and paste this gravity onto the present one. And now I need to add to that my two tensions. This big tension over here is now going to have its angle change. It's no longer going to be at this angle. It's going to have a slightly, though a greater angle measurement here, it's actually going to be shallower of a tension. This might be a little extreme, but that's okay. It helps me illustrate the point that I'm trying to make. Now, for all of these forces to be balanced out, I want you to realize that the x and y directions need to remain the same. So in order for this to work out, I need my x component to balance the new x component of this string. So my horizontal string is still just that, horizontal. So it's going to come horizontally, but it must go in a way that's going to balance the x component of this force. So that will need to be balanced. And so this length has to be bigger than this original one was. So it says, how does the force exerted by the horizontal string change? Force of the horizontal string must increase because when the pendulum angle changes, there is more force in the x component, or in the x direction. To remain balanced, and that was the key thing I was looking for, to remain balanced, force of the horizontal string must increase. So notice this loop I made. I start with my answer, do reasoning, that winds me back up at my exact answer. We should always start and end with our answer. The way I distributed points for this was I gave you 2 points for this guy, 2 points for both tensions, 1 point for the gravity. Give you 1 point for this gravity if it was the same as this one. I gave you 2 points for this guy, 2 points for this one if the angle changed. I gave you, I think it was 1 point for the correct answer and 1 point for a valid explanation. All right, so make sure that you have corrected these on a piece of paper. Turn them in with your test, as well as the stuff you learned from the videos that you watched from flippingphysics.com. Thanks for doing test corrections. Thanks for persevering, pressing in. You're amazing. I will see you soon.